My name is Yin. I work in the Department of Strategic Sustainable Development. I'm an assistant professor. Today, I would like to talk about this presentation about the approach for assessing and visualizing sustainability value of product concepts. So the approach is called SCAS, is an abbreviation of sustainability criteria and product lifecycle data simulation. We did it with GKN, mostly with Johanna, that presented earlier today, that I've watched online. The aim of having this tool is to enable the assessment of sustainability impact of different product design concepts in early design stage. And it could as well be done in a simulation environment, as illustrated here. It is not expected, but the vision is that this tool focus on sustainability, but then it could be as well used in parallel with other methods or tools that assess other values of product design. So this is the methodology. Mainly there were 5 stages. What I want to highlight is that we have done 2 stages of prescriptive study to propose the digital tool and the method of SCAS. And we have done some, so these are 2 prescriptive studies, and then we have done some evaluation studies to evaluate the results. So when I talk about SCAS, is actually an approach that we think consists of both the method and the digital tool in Excel. So this is the outline of the method that consists of 4 steps. The first step is about identifying sustainability criteria using the method sustainability design space, and also to identify the relevant sustainability indicators. This table shows some example of some important sustainability criteria and indicators related to the product. In the second version of the prototype, altogether we have 17 indicators. But maybe it's too detailed to go through them all. So the second step of this method is to identify what are the important and relevant engineering characteristics related to the product, so that it can be used as input data when people want to see different features of the product and how it affects the end results. This is where we try to map the important indicators that are related to the sustainability aspects. For example, for each design, we would like to know what are the materials used or the manufacturing methods used to create that, because it relates to all these other sustainability criteria. The third step of the SCAS methods is to define the calculation approach for each indicator. And the last step is to calculate the final sustainability mirror score for the design concepts. This diagram shows the software flowchart of how the prototype digital tool is built, from what should be input and what should be preset and what would be the input. So this is a brief overview of the method. And here I'm showing you some screen capture of screenshots of the SCAS digital tool that I talk about. So this is the prototype that I talk about that we built in Excel, but we could as well do it in other programs in the future. So this spreadsheet shows the input model. Like for these 3 design concepts, there are so many components. And all these 3 design concepts are similar product, which is an air jet component, but they are made of different manufacturing methods. That's why they are different in different features. And this second screenshot shows the list of sustainability indicators and how they are linked to the criteria and associated weighting. The weighting are highlighted in these yellow cells, which are actually quite important because it directly affects how the final result will be aggregated. And this is the page for the results. As you can see, there's a final score at the corner to show the overall sustainability merit of that design concept, which is also illustrated in this bar chart. It shows that the 3rd concept scored the highest. That means it's the best in terms of sustainability performance in this case. An interesting thing I would like to highlight is related to what I talked about in the weighting. So the first by the web are the results without the indicators results being weighted. But then the second by the web shows how after the weighting included in the calculation, then actually the score would look differently, as I have highlighted there, for different indicators. So it also affects the final scores of the product design concepts. But what is worth noting is that because the assumptions made are always the same, so the trend will be consistent. That means the best solution in this case will always be the best solution, which is always concept 3, because they are based on the same assumptions. So finally, we have conducted a focus group study, among other studies, to evaluate the value of this proposal and what are the challenges faced during the development of it. So there are 3 themes in our discussion. First is the accuracy. In overall, the participants who knew they are academic researchers and industrial researchers that understood the whole development and the whole tool quite well, they think they thought positively about whether it's accurate. And also they think a plus of this tool is that it's quite comprehensive, because all the criteria considered are included based on the sustainability design space, which is a systematic method. However, because many assumptions have to be made during the calculation, so it's actually as well limit the accuracy of the final score. But it is discussed and worth highlighting is that the final sustainability scores of the design concepts should not be just viewed as absolute scores, but they should be more interpreted as results that enable comparisons of different design concepts. Because as I've mentioned before, because the assumptions made for all these calculations are the same, so the final trend would as well be the same. Be consistent. And the second point of discussion was the dilemma in different weights used for different indicators, because depending on the weight that you use, that means what do you prioritize the most, it affects the final results. In other words, for example, if you value social sustainability so much and you do not value about environmental sustainability, for example, that it may change the result quite dramatically, depending on what is your priority or the priority of the companies. And the lesson learned is that, therefore, it's very important to be transparent and to communicate to the users and any audience of the tool how this weighting has been set and why. And in overall, the participants thought positively about the value of this tool because it enabled comparison of design concepts in quite early design stage when the data and time is really limited. That's about it.
Thank you. While we wait for Alessandro to connect, is there any questions, Jean?
Interesting work. I wonder, how do you deal with individual bias when you're weighing these indicators? Do you have some guidelines, or how does the weighing happen?
In this study, we assume the weighting will be only set once and for all. Here, set up for all indicators and the weighting. So after it's set, the tool can be used repeatedly by the companies or the users on a similar case. So the weighting is predefined like that. And how could it be defined? There could be many methods, but bias may always exist. It could be done by experts, maybe in discussion with the management of the company. And also, we have also explored other ways to define the weights, which is outside the scope of this study. And I'm going to give a presentation later today about how do we understand customer preference for different sustainability aspects, what can be the research method to do that. And if we use that method, then maybe the insights about what customers want can provide the basis for how to set the weight, for example.